Do you feel ignorant because you don't know numbers? You don't know which one go which way and they got all these marks and things on them? I know, honey, it's hard, but there is a solution. Fort Bend Tutoring. And now here go Mr. Whit. Explain math to us, Mr. Whit.
Hello, ladies and gentlemen. This is Mr. Whit with Fort Bend Tutoring, and today's tutorial is going to be about writing linear equations in standard form. That's right, standard form of a linear equation. So here we have standard form. That's right. It's ax plus by equals to c. All right, so what does all of this mean? You'll notice that our first term here is your term with the variable x, and your second term is the term with the variable y, and then you'll end up with a term that doesn't have x or y in it. In other words, just your constant. Okay, there are rules to ensure that you have standard form, but please make note, ladies and gentlemen, that standard form is not standard among all textbooks. That's right. And it really just depends on which textbook that you're using as to which form of standard form that they're going to want you to write. So what we'll do today is we'll focus on one of the most common forms of standard form, which looks just as you see it right here, the ax plus by equals c form, with the following conditions. The first condition is that a, b, and c have to be integers. That's right. In other words, no decimals or fractions within this equation. All right. Also keep in mind that your a, b, and c values need to have a GCF of 1. That's right. So you want the equation to be in its most simplified form. You don't want there to exist a GCF greater than 1. All right. So keep that in mind as far as your standard form is concerned. Then the value of a, this a coefficient right here, it must be positive. It has to be greater than or equal to 0. And speaking of 0, it's okay for a or b to equal to 0, but not both a or b. Okay, so both the a and the b value can't equal to 0, and you still have a linear equation. So only one of these values here can equal to 0 in order for you to have your result written in standard form. So keep those things in mind when you're writing out your answers for standard form of a linear equation. All right, so let's look at some examples. All right, so let's move ahead. In problem number 1 here, we're given an equation in slope-intercept form. That's right, that y equals to mx plus b form that you should be familiar with. Yeah, we have it in that form currently right now. So our job here is to write our result in standard form. So that means I need to get my x term on one side of the equal sign along with my y term. All right, so I'm going to do that by adding 4x to both sides of the equal sign here. So as I do this, I know that my 4x's will cancel out on the right side, and I'll write the left as 4x plus y equals to 5. And that's it. That's the answer in standard form. That's right. Because notice I have it in the form of ax plus by equals to c, and there you have it. All of my coefficients are integers, meaning that they're not fractions or decimals, and my first coefficient of a is positive. So I'm good. I'm going to put a box around this. All right. And that's it. That's the result of problem number 1. That's standard form. Done and done. Continuing on, we're looking at problem number 2. In problem number 2, you have the equation y minus 3 equals to 2 times the quantity of x minus 1. And guess what? This equation is written in point-slope form. That's right, point-slope form. Another form of a linear equation that you should be aware of. So, if we're asked to write this in standard form, what do we do? Well, we're going to start out with the distributive property. That's right, my favorite property in the world. And I'm going to get my arrows popping around here, okay? About to get my arrows popping, you know? So that means that I'll end up with y minus 3 equals to 2 times x, which is 2x, and then 2 times negative 1, which will give me negative 2. From here, I want to get all of my x and y terms on one side of the equal sign, and I want all the constants to be on the other side of the equal sign. So I'll start by subtracting 2x to both sides of the equal sign first. All right, that cancels out those 2x's on the right side of my equal sign. I'll be bringing down a negative 2x plus y minus 3, which equals to negative 2. From here, I'll be isolating that x and y term by adding 3 to both sides, like so. The 3's will cancel out, and then I will be bringing down negative 2x plus y, which now equals to positive 1. However, this is not standard form because notice that our a value, that a coefficient, that negative 2, it's not supposed to be negative. No. Our standard form needs to have an a value that's positive, that's greater than or equal to 0. And since that's the case, I need to get rid of this negative sign. And I'm going to do it by multiplying or dividing everything by negative 1. But it's my personal preference to divide everything by negative 1. That's what I prefer to do. All right, that's what I prefer to do. And that's what I'm going to do. So now I will end up with my negatives canceling out here. So I end up with a positive 2x here because a negative divided by a negative is a positive, right? We then have a negative y because a positive divided by a negative is a negative. And this is going to equal to a negative 1 because positive 1 divided by negative 1 is negative 1. And here comes my box. Yep, just like that, because this is the answer in standard form. There you have it. We're going to move on to the next problem now. We are so moving on to problem number 3. So in problem number 3, I have 2y equals to 3x minus 7, and I want to write this result in standard form. So that means that I need to get the x and y terms together on one side of the equal sign. So I'm going to start by subtracting 3x to both sides, like so. My x's will cancel out on the right side of that equal sign, and I'll be bringing down negative 3x plus 2y, which equals to negative 7. Oh yes, it does. However, is this standard form? Is this the form ax plus by equals to c? That's the question. No, it's not. That's right. You're correct. It is not in standard form because our a value is negative. We can't have that. We're not going to have that. Okay, so that means I'm going to divide each and every term by negative 1 to change the signs. So I'm showing right here that I'll be dividing by negative 1, changing all the signs, and a negative divided by a negative is a positive 3x. Positive 2y divided by negative 1, that's a negative 2y now. You got it. And then finally, I have negative 7 divided by negative 1. Oh yeah, you know that's positive. You knew it already. You knew that. So now we wrap things up with a red box. That's right, just like so. This is our answer to the problem in standard form, just like that. All right, let's move on to problem number 4. All right, here in problem number 4, we're given two values here. We're given m equals to 2 and we're given b equals to 12. Well, you should know from your slope-intercept form that the m represents the slope, whereas the b represents the y-intercept. So I'm going to use that form in order to come up with the initial equation. So I have y equals to mx plus b. So then I'm going to go back and replace the m with 2 and replace the b value with 12. So it looks like this. I'll have y equals to 2x plus 12. Now that I have my values filled in here, I will next manipulate this equation and write it in standard form. So I'm going to start by subtracting 2x to both sides of the equal sign here. All right. And I end up with negative 2x plus y. All right. And that's going to equal to 12. Just like that. Okay. And then what happens next? That's right. We can't have that first value equaling to a negative. So therefore, I'm going to divide, or you can multiply, everything by negative 1 to change the signs. So I'm going to do just that. All right, I'm going to divide everything by negative 1 here, and then that will give me the following result. I'll end up with a positive 2x minus y, which equals to negative 12, and this is my equation in standard form. All right, so here we are with the box that rocks. There it is. That's standard form. Let's move on to the next problem. In problem number 5 here, we're given a point and the slope. So if I'm given a point and I'm given a slope, then one way to solve it is to use the point slope form. Okay, so that's what I'm going to do. I'm going to start by labeling this point as x1, y1. All right, I already know that my slope is negative 3/4, and I'm going to use the point slope form as the initial setup to write my answer in standard form here. So I'll begin with y minus y1 equals to m times x minus x1. That's right. Once again, this is the point slope form that we're using to get our answer in standard form. So plugging in the values of x1, y1, and the slope, I'll end up rewriting this as y minus 4, which equals to negative 3/4 times x minus my x1 value, which happens to be a negative 2. All right, so it's going to look like that initially. Then we'll be combining our signs here. So we know that that negative times that negative will end up giving us a positive 2 there inside of the parentheses, like so. And then since they're asking us to write this result in standard form, and I know I can't have a fraction involved, I'm going to go ahead and multiply each and every term here by 4 because of that denominator right here. I don't want to distribute this negative 3/4 inside the parentheses to get more fractions. Why would I want to do that? Why would I want to do that? So I'm not. I'm going to multiply everything by this common denominator of 4. So it's going to look like this. I'll have 4 times y minus 4 times 4 is going to equal to 4 times negative 3/4 times x plus 2, like so. That's it. Then let's see what happens. On the right side here, these 4's will cancel out. Oh, yes. And I will be bringing down 4y minus 16, which equals to negative 3 times the quantity of x plus 2. That's right, I'm taking my time on the right side of the equation. From here, I will be distributing. That's right, I'm about to get my arrows popping. So I end up distributing here, all right? I'll have 4y minus 16 equals to negative 3x minus 6. Pick up the sticks. Okay, from there, I'm going to be getting the x and y terms on the same side of the equal sign, so I'll be adding 3x to both sides of the equal sign, and if you will permit, I'll go ahead and add 16 to both sides as well. That's right, getting 2 for 1 here. What happens now is that the 16s will cancel out, my 3x's will cancel out, and I'll end up with the following. 3x plus 4y equals to positive 10, and this is my answer in standard form. Let's go ahead and gift wrap this like so. All right, so there you have it. 3x plus 4y equals 10 is the answer. Let's move on to problem number 6. Okay, in problem number 6, we're given 2 points. That's right, 2 points. And because we have 2 points, we don't know what the slope is. We don't. So we're going to be using the slope formula first to find out what the slope between these 2 points are in hopes of getting our linear equation written quickly. All right, so the first step here is to label. So I'm going to start by labeling the first point x1, then y1, and then I have x2, y2, like so. And then remember that the slope formula is m equals to y2 minus y1 over x2 minus x1. All right, and then plug in my values here. I'll have my y2 value, which is 2, minus my y1 value, which happens to be negative 2, and we'll show that in parentheses. And this is going to be x2, which is 4, minus my x1 value, which is also negative 2, so I'll show that in parentheses as well. And this is going to reduce to 2 plus 2, because I combine my signs there. And then this is going to be over 4 plus 2, because I combine my signs here. And then I'm going to reduce that even further to 2 plus 2 equaling to 4 over 6, which reduces, oh, it simplifies by 2, by the way, to give me 2/3. That's right. That's the slope. Okay, so now that I have the slope and I already am given 2 points, I'm going to use the point slope form. All right, and that means that I'll be utilizing y minus y1 equals to m times x minus x1 to get me there. Okay, so let's plug in our value of x1, y1, as well as the slope m into the point slope formula. So this gives me now y minus my y1 value, which is negative 2, which equals to my slope, which is 2/3, times x minus my x1 value, which is negative 2. All right, so we're going to start by combining our signs here. We have too many negatives right here next to one another. And anytime you have 2 negatives right next to one another, you combine those signs using your multiplication rules. And a negative times a negative is always a positive. So I'm going to end up with y plus 2, which equals to 2/3 times x plus 2. You got it? Just like that. Now, once again, I find myself in a situation where I have a fraction involved in this equation. But standard form requires us not to have any fractions, or decimals for that matter. So I'm going to go ahead and multiply each and every term by the common denominator of 3. Okay? So doing just that, I'm going to multiply each term by 3. And it looks like this. All right? So, oh, I don't like that. No, I don't like that equal sign. We're going to fix it. All right, it looks better. It looks better now. All right, so we have that set up now, and now we will simplify. So I'll have 3y plus 6 equals to, see, your 3's will cancel out right here, and you'll have 2 times the quantity of x plus 2. All right, and we'll go ahead and take this to the next page here. All right, so notice that we've gotten rid of the fraction, but we still need to write our answer in standard form. So that means that I will be getting my arrows popping, ladies and gentlemen. So I'm going to be bringing down 3y plus 6, which equals to 2 times x, which is 2x, and then 2 times 2 happens to be 4. Okay, so we'll subtract 2x to both sides of our equal sign here. I'm going to go ahead and do this in 2 steps, all right? So the 2x's will cancel out. I'll then have negative 2x plus 3y plus 6 equals to positive 4. Then we'll subtract 6 to both sides of the equal sign. This gives you negative 2x plus 3y equals to negative 2. All right, and then because our first coefficient happens to be negative, we're going to divide everything or multiply everything by -1 to change the signs. So I'm going to divide everything by -1 because that's my personal preference. That's the way I like to do it. So I'll end up with a positive 2x minus 3y equals to positive 2, and this is our answer. All right, in a red box because it's done. Okay, so that was that problem. Let's move on to the next one. All right, problem number 7. In problem number 7, we're given a point, -1, 3, and they're asking us to find a parallel line. That's what these two vertical bars mean, parallel lines, okay? So we want a linear equation written in standard form that goes through the point -1, 3, and that happens to be parallel to the line -x plus 3y equals to 12. So the first thing we need to find, ladies and gentlemen, is the slope of this line. And the quickest way to do that is to solve for y. All right, so that's what we'll do. We'll go ahead and add x to both sides of the equal sign here. All right, and this gives me 3y, which equals to x plus 12. And then I'll divide each and every term by 3. And what we end up with here is y equals to 1/3 x plus 4. Okay? You don't like that 4? All right. Let me fix it then. There you go. That's a better 4, right? Okay, there we go. So what we want from this equation is the slope. And the slope of this equation is 1/3. Okay? So the slope equals to 1/3. And any parallel line to that has to have the exact same slope. So remember, those vertical bars mean parallel. So my parallel line slope must also be 1/3 because parallel lines have the exact same slope. So this is going to be the slope that I use in my equation. All right, from here, what we'll do is we'll use that slope as well as the point that's given to find out our linear equation. So I'm going to start by labeling the point x1, y1, and we'll use the point slope form, which once again is y minus y1 equals to m times x minus x1. Okay, and then plugging in those values into the point slope form, we'll have y minus my y1 value, which is 3, which equals to 1/3 times x minus my x1 value, which is -1. All right, so we'll have that initial setup. I will then combine my signs here. So these two negatives will combine to make a positive. So I'll have y minus 3 equals to 1/3 times x plus 1, all right? And what we'll want to do from here is get rid of that fraction, all right? So let's take this to the next page. All right, so with our equation here having a fraction involved, and we know that standard form, you can't have a fraction in your answer or a decimal, we're going to go ahead and multiply each and every term by that denominator of 3. So it'll look like this. I'll have 3y minus 3 times 3 equals to 3 times 1/3 times the quantity of x plus 1. All right. Then multiplying this out, you'll have 3y minus 9 equals 2. Here my 3's will cancel out, and 1 times anything is itself, so I'll just end up with x plus 1 here on the right side of the equal sign. Since I'm writing my answer in standard form, I want the x term and the y term together on one side of the equal sign. So that means I'll be subtracting x to both sides. All right, and then I'll be bringing down this negative x plus 3y minus 9, which equals to positive 1. From there, we're going to be adding 9 to both sides. Okay. All right, and then my 9's will cancel out. I'll be bringing down negative x plus 3y equals to 10, and then to get rid of that negative in front of that first term, all right, that a value can't be negative, we'll divide each and every term by -1. So the negatives will cancel out to give me a result that's x minus 3y equals to negative 10. And this is the answer. Just like that. That's it. Now we're moving on to the next problem. Problem number 9, we are given a point 8, 4, and they're asking us to write the equation of the line in standard form that happens to be perpendicular to x equals to negative 3. Well, what you should know is that anytime you have an equation in the form of x equals to a number, that equation is a vertical line. It's going to be a vertical line every single time. So that being the case, what type of line is going to be perpendicular to a vertical line? All right, so let me give a demonstration. Let's say that x equals a 3. Of course, you know it's going to be a vertical line. It's going to look like that. So in order for it to be perpendicular to this line, it has to create a 90-degree angle. So what does that? Well, what does that is a horizontal line. So what we need is a horizontal line, and every horizontal line is in the format of y equals to a number. All right, so well, good thing that they're giving us a point, because they just told us that the point that our line is going to go through has an x value of 8 and a y value of 4. Well, if our answer has to be in the form of y equals to a number, well, that number has to be the y value of the point that it's going to go through. So that means that your answer here is y equals to 4, and that's it. And the reason for this, ladies and gentlemen, is because we recognize that they're giving us a vertical line, and any line perpendicular to a vertical line must be a horizontal line. Also, that every horizontal line will be in the form y equals to a number every single time. That's it. So that means that we end up with y equals to 4, which is our y value from the point that was given, and done. That's the answer. Let's put a box around it. Putting a box around my answer. All right, so y equals to 4 is the result of problem number 9. And ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and that concludes our lesson on writing linear equations in standard form from Fort Bend Tutoring. So as always, please rate, comment, and subscribe, and if you're able, please donate. That helps us bring you more free videos from Fort Bend Tutoring. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? You could do all that on tutormemath.net.